Welcome back, friends. Today we will start our new topic, measurement of fluid pressure. And under this topic we will learn about manometer. Generally, manometer can be classified in two types. First is simple, second is differential. Further, simple manometer can be classified in two types, which is piezometer and U-tube manometer. Now let's learn about these several types of manometers one by one. First is piezometer. The schematic diagram of piezometer will look like this. Suppose the pressure of the fluid kept here be PA and the pressure of the fluid here is need to be measured. Suppose the height of the elevation here be H. Density of this fluid will be rho. Then we can write as PA will minus of rho G H is equals to 0, or PA is equals to rho G H. Now let's try to learn about U-tube manometer. Suppose fluid is kept here that has density rho 2 and the fluid here has density rho 1. Then the equation is written as PA plus H1 rho G will be equal to H2 rho 2G. Now from here we can find the value of PA as G into H2 rho 2 minus of H1 rho 1. Now one thing to keep in mind, in several questions they also tell you to consider the atmospheric pressure PA. That is, the manometer head will not be closed, it will be open, so the atmospheric pressure will also act on it. So an extra term as PA will be added on the right hand side. So now PA will be equal to G into H2 rho 2 minus H1 rho 1 plus PA The huge application of U-tube manometer is where we need to measure the pressure of the two sections of a pipe where the fluid is flowing. For example, in venturimeter that you will learn in the further tutorial, let me give you a brief idea. Suppose it is a venturimeter and the fluid is flowing here. Here we need to measure the pressure between the two sections, that is the pipe section and the throat section. So a U-tube manometer is inserted between these two sections, and a manometric fluid, generally considered as mercury, is used in this manometer. Because of the pressure difference at section 1 and section 2, a rise will take place, which is measured as del Y, which is included in the calculation of discharge of water through venturimeter. Now the next type of manometer is number 3, differential manometer. Differential manometer is also classified in general two types: U-tube differential manometer and inverted differential manometer. U-tube differential manometer is very much similar to the simple U-tube manometer. Here, the difference is, you will see in the schematic diagram, that the second side of the manometer is not opened. It contains some fluid at a given pressure. That is, if this part has pressure PA, this part will have pressure PB. Here, three different kinds of fluid are used for part A, for part B, and the third fluid is used to measure the elevation. Suppose the third fluid has density rho 3, here rho B, and here rho A. So now the equation is written as PA plus, if the height from this to this section is H3, from here to here is H2, and from here to here is H1, then H1 rho G equal to rho 3 H3G plus rho B G H2 minus H3 plus PV. Now we can measure out the pressure difference PA minus PV as rho 3 H3G plus rho B G H2 minus H3 minus of rho A H1G. An inverted differential manometer is quite similar with U-tube differential manometer. The only difference is it looks like it has an inverted form of U-tube manometer. Here, if this pressure side has PA and here PB, the elevation here it has H1 and here as H2, then we can write the equation as PA minus of H1 rho 1G if the density here of this fluid is rho 1, of this fluid is rho A, and of this fluid is rho B. Here minus sign is used because the pressure we are measuring is below the datum line. Minus of H3 minus H1 rho A G equals to PB minus of H2 rho B G. Pressure difference will be equal to PA minus of PB equals to H1 rho 1G plus H3 minus of H1 rho AG minus of H2 rho BG. Now the last type of manometer which we use is inclined manometer. It is look like one side of the manometer will be same as simple manometer while the other side will be at some angle. The fluid used will have some elevation. If this is the datum line and L is the length along the inclination, PA is the pressure here, the density here, is rho, then height from the left side be h, then PA will be h1 h rho g will be equal to, if the density here is considered as rho A, then here we will write h rho Ag will be equal to h dash rho g, where h dash is the vertical length of the inclination, that is this. If this is theta, then h dash will be L sine theta. So PA will be L sine theta rho g minus of h rho A g. Now we have come to an end of the topic pressure measurement through manometer. Now, before winding up this tutorial, let me give you some important points to remember while solving the questions. If the bottom line is considered as absolute zero pressure and this line as atmospheric pressure, then the pressure that we generally measure from the manometer is gauge pressure, which is this. Now, the absolute pressure is nothing but the summation of atmospheric pressure plus gauge pressure. Now, the amount of pressure from PATM to gauge pressure is same as downward, which is known as vacuum pressure. Now, numerically we can write as absolute pressure will be equal to atmospheric pressure plus gauge pressure. Vacuum pressure will be equal to atmospheric pressure minus of gauge pressure. This absolute pressure and vacuum pressure is really required while solving some numericals, because somewhere you need to find only the gauge pressure, that means the atmospheric pressure is not included, while somewhere you need to find the absolute pressure where you have to include the atmospheric pressure. Now, some important conversion for your examination point of view. 1 bar is equals to 10 to the power 5 Pascal or 100 kilopascal. 1 atmospheric pressure is equals to 101.325 kilopascal. 1 torr is equals to 1 millimeter of Hg, that is mercury. That's all from this tutorial of pressure measurement through manometer. Thank you.